So if you have $17 and spend $9, how much money do you have left? So hopefully we know that that'd be $17. That's how much you have. You take away $9, boom. You should have $8 left over right there, right? Or if you read for 1 hour and play video games for 5 hours, how much longer did you play video games than read? Well, you played video games for 5 hours. You read for 1 hour. And when you subtract those, it turns out you read for 4 hours longer than you read. Hopefully that's actually switched in real life, but it's probably not common. Now you'll see on the classwork that it says it has a place for you to write the objective. That's what we're going to do right now. The objective says I can evaluate math expressions with the order of operations. So take 1 minute and copy that down. The second part there that says we got a quiz today, that's not, you don't have to write that down. But the objective you should write down.
Where do we write each?
So the objective, why do we write down the objective? It's because the objective tells us what we should expect to learn for the day. And if we learn what we should learn for the day, then we can look back and say, oh, that's right. That's what our objective was. And we did do that thing. And then we can feel good about what we did that day. We know we worked hard, we listened, we paid attention. And it means that you're now ready, not only for the assignment, but for the lesson next time, too. So absolute values, you guys did do a little bit of absolute values last year in 7th grade. Just remember that the absolute value is the distance a number is from zero. How far, like that's when you see an absolute value symbol, which is these symbols, they're also treated like parentheses, but it becomes a question of how far is it from zero. So if I saw a number in between those absolute values, like 8, right? I'd say, well, how far, that's really asking how far is 8 from 0. And hopefully you know that the answer to that is 8, okay? On the other hand, though, if I put a negative with that 8, the question is still, how far away is negative 8 from 0? And as it turns out, negative 8 is still 8 away from 0. Why are both of them positive? It's because distance is never looked at with negatives, right? If you said, hey, I live negative 10 miles north of here, people may look at you weird and, well, we would think you'd make a good politician someday, okay? Like, it's a good way to trick people. So we don't look at distances in terms of negatives. And so the example here as well, 7, right? The absolute value of 17 is asking how far 17 is from 0. Well, how far away is 17 from 0? It's 17. 17 what? Units, marks, whatever. Just it's 17 from 0. Do keep in mind that absolute values are not opposites, because some students think that it is. It's like if you saw, if you go back up here at the top, and you saw positive 8, they say, oh, it's opposite, so it's going to be a negative. No, that is not true. It's not negatives. It's just always positives. That's it, okay? Because it's a distance. It's asking for a distance from 0. So here we go. That's an absolute value symbols here on the edges. And sometimes it's hard to tell the difference between these little marks for absolute values and ones. But it should be, hopefully, at least slightly clear. But this one is asking, right, the absolute value. This is how this reads mathematically. The absolute value of negative 756. The question we really should be asking in our head here is, how far is negative 756 from 0? Right? How far away is this number from 0? And hopefully we would then know that the answer to that is 756 units. So a lot of the stuff that we're going to be doing, as it turns out, you'll find that it's really just asking the right questions sometime. Okay? And we should be asking lots of questions. Just like we talked about in the classroom introduction with both dialectics and the trivium. So what about this expression right here? You got the negative 3 minus negative 4, but it's the absolute value of that, okay? So like I said, we treat these absolute values as though they were parentheses, okay? So that's an order of operations kind of thing. In any case, inside that set of parentheses, we have an operation of subtraction, okay? And now, with subtraction, we're actually subtracting negatives. First thing I notice here is that I got a negative and a negative. In fact, with negatives, whether it's addition or subtraction, I always want to add these values. So How do I change this operation from subtraction to addition? It's called, well, most students like to think of it as keep, change, change. And this only with relationship to the signs. So the numbers, you'll notice, will stay the same. But it changes the sign. So keep, change, change. You see this first negative right here? It's going to keep negative. Then we change the operation from minus to plus. And then we change the next sign into, from this one, negative to positive. So I can show this positive 4. We shouldn't have to, though, because positive signs we don't need. Okay, so this ends up being negative 3 plus 4. Why did we do that? Because hopefully you remember that we really only ever add with negatives. We never subtract with them. So if we ever see subtraction with negatives, we change it to an addition sign. Okay, well, then what? Well, we got to operate within these absolute values right here. And I'd look to add those two values. So I got negative 3 plus 4. We hopefully remember that when signs are opposites, as they are right here, with a negative 3 and a positive 4, the first thing we want here is to figure out the sign of the answer. Then it's just a straight operation after that, okay? But how do we know what the sign is? Well, we look at the 2, and we see which one is bigger, and the 4 is bigger, and it's a positive, so that means that the answer here will be a positive. And then you just take the big number, which is 4, and you subtract the small number, which is 3. 4 minus 3 is 1. And right now, then, I have the absolute value of positive 1, which is just, well, 1. And that, right there, would be our final answer. And that's a nice quick review on operating with negatives, at least with addition and subtraction, hopefully. So, order of operations, and hopefully you learned this last year, but if you've forgotten, that's okay. We're going to review it right now, right? So, a lot of students think of order of operations as PEMDAS, or please excuse my dear Aunt Sally. But it's not always please excuse my dear Aunt Sally, because, as we can see here, parentheses and exponents, that's true. The P and the E, they're always in that order. But the MD and the AS are not always in that order, okay? And you can see here, multiplication or division occurs from left to right. So we're going to scan these from left to right. And if we see division first, we got to do it first. Or when we look at addition or subtraction, if we see subtraction first, scanning from left to right, we have to do the subtraction first. So you need to be careful with this because sometimes students get so caught up on PEMDAS, and it's like, oh, multiplication is always before division. No, that's horse crap. It's not. Sometimes division comes first, and it's just a matter of scanning these problems from left to right. So that means PEMDAS could be PEDMAS, or PEMSA, or PEMSA, I don't know, something like that. So let's evaluate this expression right here. Now the order of operations says that we should do parentheses first, but I'm not seeing any parentheses, and that's okay. Next thing I would look for is exponents. Do I see any exponents? Yes, I do, right here. There's an exponent of 2. And hopefully we remember that exponents is just a simplified form of repeated multiplication, which means that 4 is going to be multiplied by itself. We're going to see 2 4s being multiplied. That's from the exponent 2. Now notice I'm not concerned about that negative 5 or the addition right now. I'm just concerned with the 4 to the power of 2. So what is 4 to the power of 2? 4 times 4 is 16. Yeah. So now I have negative 5 plus 16. So now that I've done that operation, I now look to the rest of the problem now that it's been evaluated. Okay, and then I can evaluate that next part. And this is the nice thing about the order of operations, is the order of operations will always break up larger problems into smaller, more manageable parts, which we talked about during the introduction. That's how good problem solvers work. They'll take big problems and then break them down into smaller parts. That's what the order of operations does. It's programmed into mathematics, so it's almost to the point where we don't necessarily have to think about it, right? So that's all I was doing, just focus on this one. And next, now that we've evaluated that, okay, it looks different. This expression here looks different, but it is the same as this one, it just looks different. Okay, and that's kind of an important skill with mathematics, because if you can do that, there's really no limit that you can do in mathematics, even up to calculus. So now I am adding, one of the values is negative, right? We got two opposite signs, we got a negative and a positive. So just like we saw on that absolute value problem here, is I got to combine these, but I'm looking for the number that's bigger, and the 16 is bigger, which means the sum here will be positive, because the 16 was positive, it's bigger. Since the signs were opposites, I'm going to take the big number, 16, and subtract the small number, 5, and that will be, well, that's the value of the sum, but then I just attach the sign to it, so that's positive. I don't need to show positive signs, it's just 11. It's okay to say positive 11, but it means the same thing. Right? In PEMDAS, we notice, or order of operations, we notice that multiplication comes right after exponents. It's just exponents is what kind of forces that part of the multiplication to happen first. But yes, exponents are just simplified multiplication. It essentially ends up being the same thing. All right, here's one, and we got some subtraction this time. But what we're seeing on this one, yeah, there are parentheses. Okay, and some students are like, you got to work inside the parentheses. Well, what work are you going to do in there? There's nothing to do inside these parentheses, which means inside the parentheses, they're already fully simplified or evaluated. So you don't have to worry about doing any operations within the parentheses, which is what you would do if there was more stuff there. But it's just numbers, which means that we can move on to the next operation, which would be exponents. Well, I don't see any exponents on this one, so we're going to move then to multiplication or division from left to right. So I'm going to scan this thing starting from the left. Okay, that's just -3, no multiplication or division. There's minus, so that's not the operation we're looking for. And here we see 2 and 5, and we don't see the operation. The only operation you'll ever not see is multiplication. So if it helps you to see this, you're welcome to put a little multiplication sign between there. But you don't have to, because multiplication is the only operation we don't have to show sometimes, okay? So I can operate between the 2 and 5 because we are at multiplication and division from left to right. 2 times 5 is 10. So now I got -3 minus 10, right? So, but I have a negative here, and I don't want that negative. Well, I don't mind the negative. It's the minus that's going to throw me off. What I want to do is change that into an addition sign, okay? So once again, I'm going to perform keep, change, right? And this is only regarding the signs. So keep, change means that this -3, that's the keep part, I'm going to keep it -3. Then I will change the operation minus into plus, because remember, I only add with negatives. And then the 10, it's not showing the sign, it is positive though, okay? The 10, which is positive, I'm going to change into a negative. If you prefer to keep that in parentheses because it's negative, that's fine. But while you're just doing this on your own, it's not necessary that you do. But that may help. So now I have 2 negatives being added. So this is the first time we've seen this school year anyways. When I see that the 2 values that I'm adding are negative, that means that the sign is going to be negative of the answer, because I want to figure out the sign first. Since I know the sign is negative, I'm going to take the 2 values, 3 and 10, and I just need to add those together. Because when the signs are the same and you add them together, it's just going to give you a bigger value of that sign. So in the ones place, I got 3 plus 0, which is 3, and then the tens place, I'll just drop the 1, 13. I know some of you could have done that in your head, and that's great if you can, but I thought it'd be good to show the work there. So -13 is what we end up with. And notice here that the order of operations took a expression that had 3 values in it, -3, 2, and 5. It then reduced it into 2 values, and then it reduced it into 1 value. That's completely simplified. That's what we'll always want with these order of operations type problems. All right, order of operations. Now you'll recall, so on the worksheet you saw in the order of operations with parentheses, you just saw this little line like this. That's not a negative sign. That's a fraction. And so usually it was supposed to print with boxes here and here, but it didn't. Stinking jerks. Okay. So when you see a fraction line like this, we treat the numerator and the denominator, if it helps you at the top or the bottom, as their own set of parentheses. Okay. So when I do this problem right here, I'm going to take this. I just need some space, so I'm going to move it over here. I'm going to just focus on the numerator or denominator first. I personally focus on the numerator first. Well, what if you want to focus on the denominator first? Do it. I don't care. It's the same thing. It's one set of parentheses or the other. You got to start with one. Okay. So for this problem, I'm just gonna give myself another set of fraction line like this, okay? And then if I need more, I can put more out there, right? But I'm just operating with the numerator, so I'm completely ignoring the denominator here, completely ignoring it, right? So in my numerator, I got 1 plus absolute value of 15 plus 4. Okay, now remember, we do treat absolute values as their own set of parentheses, and there's operations in between. So I'm going to operate just within that set of absolute values, but I'm going to add 15 and 4. Now, if you needed to show the work for that, that's fine. Some people are too ashamed to. It's like, if I have to show my work for this, I'm going to feel stupid. You shouldn't, because it's good practice to show your work. Okay, so 5 plus 4 in the ones place value is 9. I drop the 1 in the tens place value is 19. So I have 19 in my absolute value. Now, even in the numerator, I was ignoring that one plus right there. Okay, and that's because of the order of operations. But now that I've completely simplified everything on the inside of that absolute value, I can show it. So I get 1 plus the absolute value of 19. Or, how far away is 19 from 0? And that's my next step, is how far away is 19 from 0? It's 19. So I end up with 1 plus 19. Okay. And that's not too bad. And again, if you need to show the work for that, that's fine. 1 plus 19. Ones place value 9 plus 1, or 1 plus 9 is 10, so carry the 1. In the tens place value, 1 plus 1 is 2. So there's 20. Now that's completely simplified. That has completely simplified the numerator. So I'm done with the numerator right now. That's it. What I need to do now is work with the denominator. So I go back here to the left, and I see I'm subtracting with the negative. Oh, that stinking garbage, right? So I got to use keep, change on this. So that means I'm going to keep the 3 negative. I'm going to change the operation from subtraction to addition. And that 2, which is positive right now, it's going to change into a negative 2. And I'm putting parentheses just to clarify that it's not plus minus, it's plus negative 2. Okay? So now I have addition of 2 negatives. 2 negatives, they're the same sign, and I'm adding, which means the sign of the sum here will be the same. And then I take the 2 values, 3 and 2, and add them together. 3 plus 2 is 5. Now, the sum here is not 5. Remember that we had the sign being negative, so it's actually negative 5, okay? Whenever we add or subtract, whenever we operate with negatives, the first thing we always want to do is figure out the sign of the answer. In this case, it was negative. Then we operate with just the values. This is negative 5. Well, what else is there to do with that negative 5? Nothing. So I'm just going to move it over here into my other denominator. So what I have now is 20 divided by negative 5. And with division, I mean, if you need long division, that's fine. In fact, I'll show it. But the first thing you should do is figure out the sign of the answer. In this case, I'd say there's a positive and a negative. A positive and a negative makes a negative. Actually, for me, I'd say that there's only one negative. One is odd, so the answer is negative. We'll talk more about that later, I think. In any case, this is 20 divided by 5. Notice I'm not putting the negative with the 5 because I already know the answer is negative. I can ignore the negative now. How many times is 5 going to 20? 4 times. 5 times 4 is 20, and you get 0 remaining. Okay? So the quotient there is 4, but my final quotient ends up being negative 4. And, well, that's as far as we can go. You can only ever reduce these down into one final value, which in this case is negative 4. So once again, we took something large, right? The original problem had 5 different values. We then reduced it to 4, or 2, and then 2, 1, and 1. 2, 2, 1, 1, 1. Well, 2 right there, and then 1. So evaluate this expression. Are there parentheses? Yes, there are. Okay, let's do those parentheses then. Okay. And once again, even though there is the exponent on the outside, I'm only focused on the parentheses here. Now, I work with fractions from left to right, so I kind of do this horizontally. But you've noticed from the past, whenever we do multiplication, addition, or subtraction, I work downwards, but whatever. You can decide now whatever works best for you. So I got negative 24 divided by negative 4. And I'm still within the parentheses. You can show the parentheses if you want, but I'm going to take this fraction here, right? Now, the first thing here that I notice is, well, actually, there's no real operations on the inside. There's just one final operation. So I guess I shouldn't need that fraction line right there, right? But what I do notice here is that I got two negatives. 2 is even, which makes my answer positive. Why do I want to figure out the sign of my answer first? So I don't have to worry about those stinking signs. So I put the positive sign out there, and then I can just operate with just the values, 24. And again, if you need to use long division, that's fine. 24 divided by 4. 4 goes into 24 6 times. 6 times 4 is 24. Boom, nothing remaining, right? So I end up with positive 6 here. And now I don't really need that positive sign, and I'll keep the parentheses. Why am I doing that? Because in the original problem, there's the exponent. So I need to show that now that I've evaluated the inside of the parentheses, right? We do everything on the inside first, and then we focus on the outside. So that's 6 to the power of 2. I'm going to expand that. Instead of showing it as an exponent, I want to show it as repeated multiplication, which is 6 times 6. 6 times 6? Yeah, 36. Boom. Here's a good one. We got 2 sets of parentheses. We got some division there. Why don't you guys take 1 minute and try this one out? Okay, 1 minute, go. I mean, just real quick, I got -5 on this one. Okay, now how did we get -5? Let's find out. So the first thing I do here is I'm going to focus on my parentheses, right? Now I'm still always scanning these from left to right, so I start with the one on the left. Could you do the one on the right first? You could. You could, but I like scanning from left to right and to kind of keep that constant. So I'm going to take -13 minus 7. But I got a negative and I'm subtracting here. I don't want to do that. I'd rather add with negatives. So I'm going to use keep, change, keep 13 negative. Change the operation from minus to plus. And then that 7, which is positive, I'm going to change that as well into a -7. So there's another set of parentheses for us. Very nice. And now that I have both values that are negative and we're just dealing with addition, I can combine them. So what do I get? I get -13 plus -7. Since I have 2 of the same signs, and I'm adding, the answer will be the same sign, and they're negative. So the answer is negative here. Okay, well, they're the same sign, so I'm going to take both values, 13 and 7, and I just need to add them, and then in the end here, I'm just going to tack that sign onto it. So 13 plus 7, 3 plus 7 in the ones place value is 10, carry the 1. In the tens place value, 1 plus 1 is 2. So I end up with not just 20, but -20. But once again, notice I was not focused on the division. I was not focused on the other parentheses. I just wanted to focus on one part at a time, okay? So I've done that. Now I will look at the rest of the expression. Yeah, we do have the division there. That's fine. But I now want to look at this other set of parentheses, right? Because we're still on parentheses. We're not on any of the other operations. Still parentheses. And this one's already addition with the negative thing. So that's good. That's good. We can combine these right now. -1 plus 5. They're opposite signs. The 5 is positive. It's bigger, so the sign of the answer here will be the same sign, which is positive. Now I will take the bigger value, 5, and subtract the smaller value, 1. 5 minus 1 is 4. I end up with a positive 4 on this. So then I can move that down, and I end up with -20 divided by positive 4. In fact, I don't really need to show the parentheses, although you're welcome to. But I got -20 divided by 4. Well, if I divided these, what would be the sign of my answer? Well, 1 negative, 1 positive. They're opposite signs. It's a different operation now, though. For me, I just count the negatives, but 1 negative, they're opposite signs. However you want to look at it, this answer is going to be negative. Now that I have that, I can take the two values and, well, divide them. So that'd be 20 divided by 4. Well, 4 goes into 20 5 times, and 5 times 4 is 20, so yeah, that's nothing remaining, that's nice. But I end up with -5, just like we thought in the beginning here, and that's it for this one. Let's do this one together. Going through our order of operations, are there parentheses? Yes, there are. What can you do in the parentheses? Nothing, so we're done with parentheses. Let's go to exponents then. All right, is there any exponents? Yes, there is. I have this exponent of 2 right here. So that means the base, which is negative 3, is going to be multiplied by itself twice. In fact, I'm going to show it in parentheses twice. Negative 3 and negative 3. Okay? So negative 3 times negative 3, because I'm still on the exponent, is, there's 2 negatives, so my answer is positive. Or you could say it's a negative and a negative is positive. That's fine. 3 times 3 is 9. Bam. Okay, I've evaluated that part. There's nothing else to do there, so I'm going to look now at the rest of the problem. So I got 9 minus negative 28 divided by 7. So that takes care of all of our exponents in this problem. Are there any other next operations, right? So multiplication or division. Is there any multiplication or division? Yes, there is. I got some division right there. Now that means I'm looking at dividing negative 28 and 7. So negative 28 divided by 7, I know that from these two, one is negative, one is positive, so the answer will be a negative. And then I just do 28 divided by 7, which is 4. 4 times 7 is 28. You get nothing remaining, which is what we want for now. Here's negative 4. So now I got 9, because that took care of those two terms, those two values. So now I got 9 minus negative 4. I'll put that in parentheses. So that was all the multiplication or division, scanning from left to right. Now I'm on, well, there's only one operation actually, so I don't really need to worry about looking at any other operations, just minus. That's 9 minus negative 4. I'm subtracting with the negative. I don't really want to do that, so I'm going to use keep, change, change. Keep the 9 positive. I'll change the operation from minus to plus, and then the 4, which is negative, will change to positive. This ends up being 9 plus 4. 9 plus 4, you can stack it if you need to. 9 plus 4 in the ones place value is 13. Carry the 1, right? So there's 13. That's it. Order of operations. Is there any parentheses? No, not like formal parentheses, but we do have that fraction right there. That's no good. Now there's nothing to do in the numerator and denominator separately, but we can do 8 divided by 2. 8 divided by 2, that's really what that reads right there, is 8 divided by 2. That's what fractions are. Fractions are division. 8 divided by 2 is 4. Yep. So this ends up being 4 from that fraction. Of course, we still have the rest of this. All right, we still got the negative 5 minus 5 plus 4. So that really takes care of the parentheses, which means we're on exponents. I don't see any. Multiplication or division, you could have said that was division. That's fine, but it's done. So really only on addition or subtraction. The good thing about this problem is we need to know that you're not going to do 5 plus 4 first. You should not do that first. Why? Because the subtraction's happening first on the left. So that's what we're going to focus on right now, is just the negative 5 minus 5. That's all I want to see. Yeah, I'll worry about that plus 4 here in a second. But for now, just negative 5 minus 5. And we're subtracting and we have a negative. I don't like that. I'm going to change that into addition. Do you have to? No, I mean, if you guys got that down, that's fine. But I'm going to change it just because I want to stay within the parameters we've set. So keep, change, change. So the negative 5 stays negative 5. The operation changes from minus to plus. And that 5, which was positive, changes now into a negative. So I got negative 5 plus negative 5. When I look to combine these, which I'm doing now, with addition, the signs are the same, so the answer will have the same sign. And then I just add the two values, 5 and 5, which is 10. So it's not just 10, though. It's negative 10 in the problem. And then I will look at my plus 4, because we took care of those first two values right here. So remember, yeah, we're always changing these. We really only work with two values at a time. So there's the 2, and then we work these two, and now we're working with these two. So that's negative 10 plus 4. It's a negative, but we're working with addition. That's nice. When I combine these with addition, the bigger value will be the sign of the answer, and the 10 is negative. It's bigger than 4, so the answer is going to be negative. All I do now is take the big value, 10, and subtract the other value, smaller value, which is 4. 10 minus 4, 6. So my final answer here ends up being negative 6. Here's more, and again, this is A problem like this is only set to make sure that you're not going to do 14 plus 74 first. We do not want you to do that first because in the order of operations, even though there's no parentheses, exponents, or multiplication or division, we want to make sure that you know it's subtraction or addition or subtraction from left to right. So you need to scan this from left to right. Oh, there's the subtraction right there. I got 33 minus 14. And now some of you guys be like, well, I'm going to change that to keep change, right? No, there's no need because I have something big taking away something small. So I can do that. I can do that subtraction right there, 33 minus 14. I'm just going to stack it in the ones place value, 3 minus 4. I'm going to borrow from the 3 there. That's 13 minus 4, which is 9. And then in the tens place value, 2 minus 1 is 1. So when I combine these, I just get 19. Now I will add the 74. No need for keep change here because we've got two values that are positive. So we can add these directly. That's 19 plus 74. Whatever I get here is going to be my final answer. 9 plus 4 in the ones place value is 13, carry the 1. In the tens place value, 1 plus 1 is 2, plus 7 is 9. Now, right now, I'm not using my fingers to add those, but some people get kind of ashamed to use their fingers to count, right? Like 9 and then plus 4, 1, 2, 3, 4, and they get 13. You shouldn't be ashamed to use your fingers when you're using math because even at the highest levels I've seen professors use their fingers to do that counting. So it's okay to use your fingers when you're adding or even subtracting, okay? All right, order of operations on this one. Well, we do have a set of parentheses, which is nice. So we're going to focus on that set of parentheses. And that shows 6 minus 2. So I'm only focused on 6 minus 2. Now, this is something big, take away something small. I can do that. 6 minus 2, that's 4. Now I just look at the rest of this. 3 plus 4, that's times 4. Remember, we're not seeing that operation, but it's there. It's multiplication. So that's the parentheses. There's no exponents, but now I do have that multiplication with the 4 and 4. And 4 times 4 is 16. So now I have 3 plus 16. We're down to one operation, which is nice, because whenever you're down to one operation, that's all you got to do. 3 plus 16, you can stack it again if you need to, but whatever. In the ones place value, 3 plus 6 is 9. Drop the 1, 19. All right, this one, 9 divided by 3 times 2. You guys take 30 seconds. Try this one out, then we'll go over it, okay? So we want to make sure on this one that you're not going to do 3 times 2 first because of multiplication or division, which in that case you get 6. But you can't do that first because, remember, it's multiplication or division from left to right, so we've got to do the division first. That's the 9 divided by 3 right there. So 9 divided by 3, that's what we want to do first. That's 3, and then multiply by 2, which is 6. So the final answer is 6. But we don't want to do 3 times 2 first, which is 6, and then 9 divided by 6. You could get a fraction. You can get fractional answers. That's fine. It's just that's out of order right there. All right, so there's our objective. I can evaluate math expressions with the order of operations.